Today we'll be going through a problem in section 2.4. So this week we've been studying sections 2.3 and 2.4, where we first in 2.3 learned about operations on sets, and in 2.4 we're learning on applications of what we've learned throughout the chapter. The main application that we're studying are survey problems, and so that's what I wanted to go through an example of, is a survey problem. So we've written on the board here the problem that we'll tackle for the moment, and it is 2.4 example. A survey of 72 students at UMO produced the results listed below. 22 took history, 23 of those students took math, 28 took religion, 15 took history but not math, 9 took math and religion, 11 took both religion and history, and 4 students took all 3 of these subjects. Now, there are some accompanying questions that go with this, and when you go to do your homework assignment in the Hawks homework, they'll typically only ask you one question at a time. But I figured, so we have extra practice, we'll talk about several different questions related to this scenario. So the first question we'll be able to answer is, how many students in this group took only religion? Right? In other words, 28 took religion, but that doesn't say that they only took religion. They might have taken religion and some other classes, like history or math. Second question, how many took math and religion? Third question, how many people took religion but not history? And the fourth question, how many of the 72 students didn't take any of these 3 classes? So we're going to investigate that using what we learned about the concept of a Venn diagram. It allows us to visualize the numbers in this problem. So sometimes students look at a problem like this and they get kind of overwhelmed and they're not sure where to start. So part of what I want to talk about is a strategy for how you would approach a problem like this. So the first thing you want to do is draw yourself a Venn diagram. Remember, a Venn diagram is a visualization of a set. So you kind of think of a set as a collection of objects, but when you visualize, you kind of think about it like a box. Like, here's a box where I put all my objects in. And you can divide up the box into pieces. Like, part of the box is where I put certain things, and part of the box is where I put other things. And that's essentially what the Venn diagram represents. You say, like, I have a box full of names of students, and all the students that took history are going to be in this circle in the box. And then all the students who took math will be in this circle in the box. You don't have to draw perfect circles, because the whole point is just the locations are representing the history students, the math students, and then finally the religion students. And so when you draw these circles, you make sure they overlap in this sort of almost triangular fashion, where you'll have these outer pieces of the circles, and then you'll have what I would call the petals. Like this part here I would consider like a petal. And the 3 petals of the circle, of the 3 circles, all sort of centralize into a center part where all 3 circles come together. Now, that's where you want to start with solving one of these problems. So you don't want to get yourself overwhelmed with trying to guess or think about the answers to these questions. All you want to do to start with is figure out how to label the Venn diagram correctly. And you always want to work from inside out whenever possible. So the inside of this Venn diagram, again, is this middle part where all 3 circles intersect. That's going to be the part representing the students that took all 3 of these classes, history, math, and religion. Notice that's the last thing that was told to us in the question, that 4 students took all 3 of the classes. And so I'm going to put a 4 in here in that middle of all 3 circles to represent that these 4 students took all 3 classes. Right? These students are inside the history circle, they're inside the math circle, and they're inside the religion circle. Okay, now to go out from there, I said work from inside out. From inside out, you would then go to filling in the 3 parts of the petals. And then you would eventually get to these like Mickey Mouse ears, I like to call them, right? The outer pieces of the circle. And so to get the petals, you're talking about whether a student took 2 different classes. Like if I'm looking at this petal right here, from here, like that, this would represent the students that took both math and religion. Okay, so let's start off, we'll just start backwards here with the history and religion first though. 11 students took history and religion. Can you see which petal that would be? Let me kind of highlight it perhaps. in a different color. So history and religion is this petal right here. And we're told that there's 11 students that should be in that section of the diagram. Well, so far we have 4 of them. Notice there's like kind of 2 halves to the petal. There's the half with the 4 and the half that I haven't put a number in yet. So I can think about it like this. I think about it like I have history and religion together, and I need 11 total students to be in that petal. And so far I have 4 of them, plus a number that I don't know yet, the number that's not filled in. So 4 plus x. Then I can solve this algebraic equation by subtracting 4. So x is 11 minus 4, or in other words, 7. So that tells me that I will have 7 people in that part of the diagram, and the 7 and 4 together gives me 11 total students in that petal representing the number of students that took both history and religion. So I'm going to do a very similar thing with the petal involving math and religion. We're told that there are 9 students that took both math and religion. So that will lead us with 9 equals. Notice again, there is now a petal here involving math and religion. And we can see that we've already got 4 students taken into account. But this part of it's unknown, so we'll call that x, right? That's what you use the variables for, is when you don't know something. You call it x or another letter. And so you then solve for x. X is 9 minus 4, or 5. And that will tell us that the 5 goes right there. Okay, now we're thrown for a little bit of a curve, because the next thing that we're told in our problem is that 15 students took history but not math. So you can think about each of these statements here as kind of like clues that you need to finish the Venn diagram. That's a different type of clue than the last 2 we just used. It's not telling us that 15 people took them both, but it's telling us that 15 people took history and they didn't take math. So what you want to do is you want to think about the picture in the context of what's the part of the circle that's the history circle that doesn't touch the math circle. Right, the history circle is this whole thing. Right, the history circle is this whole circle, and it consists of lots of little parts. Now, this is the math circle. So if we're trying to avoid the math circle, we want the history students that didn't take math, then we don't want to touch the math circle. We want to be just like this part here, but then we want to stop short and only be talking about basically over here, not the petal itself. So history but not math would be what would be up next. History and not math. We have 15. Now, we have 2 parts to the history but not math. You know, it kind of looks like a Pac-Man almost head, if you remember that video game from the olden days. And you have this and this have to add up to 15. In other words, the 7 here and the part we don't know has to add up to 15. Thus, when you solve the algebra equation again, you get x is 15 minus 7, or 8. That tells us, again, that this part is 8, which makes the part of the history circle that doesn't touch the math circle add up to 15. 8 and 7 give us 15. Okay, so now we've gotten sort of that next level. We started in the very middle. We essentially took care of these one at a time, and we're working our way back out. Right? So the information is usually told you in this order, but you often work it in reverse to figure out the Venn diagram. So now the last 3 things are the overall totals of history, math, and religion students. And which one of those you start with depends on what your picture looks like at this point. So what you want to look for is a circle. Like each of these circles, you'll notice, has 4 pieces. 8, 7, 4, and then a blank. This is a blank, and a 4, and a 5. And this is a 7, 4, 5, and a blank. And what you want to do is start with one of the, it doesn't matter which one actually, but one of the ones that only has 1 blank left. So see, history only has 1 blank left, so I could finish that one off. Or religion only has 1 blank left, so I could finish that one off. So let's go ahead and start with finishing off the history circle, since that one only has 1 blank. notice that we already have 8 and a 7 and a 4 and then a blank, and we're told that the 22 students took history. So we will say that history uses the 22 total students, has to equal 8 plus 7 plus 4 plus our unknown fourth piece, which we'll call x again. When we go through it and solve that, you can see that 8 and 7 and 4 add up to 19. So that's really just saying that 22 equals 19 plus x, or in other words, x equals 3 when we subtract 22 minus 19. And that gives us the last part of the history circle. At this point now, notice we filled in one of the math pieces at the same time as doing that, so we could finish with either math or religion, either way. But let's go ahead and finish with religion, and then we'll do. As I was saying, at this point you can finish off either the math portion of the Venn diagram or the religion portion. Let's just go ahead and take care of the religion one first. We're told that there were 28 students that took religion, so 28 equals, we've got the numbers in that part of the circle already, 7, 4, and 5, and then the unknown in the fourth piece, so it'll be 7 plus 4 plus 5, again, plus our unknown, and solve for x. So 7 plus 4 plus 5 is 16. That gives us that 28 equals 16 plus x. And if you solve the equation in the same way we've been doing the others, that would lead you to x equals 12. So we'll put our 12 here. We've got just the one more circle piece to fill out, and then we have to consider what's going to end up being our last question, which is, were there any students who didn't take any of these classes? But let's finish off the math first. So with math, we were told there were 23 students that took math. So 23 equals, and we know we have 3, 4, and 5 of them taken into account so far, and then the unknown. So 3 plus 4 plus 5 plus x. That leaves us with 23 equals 12 plus x. So then x would be 11. We filled out the last part of the math circle. One last thing to do, as we said. Figure out, were there any students that didn't take any of the 3 classes? It said we surveyed 72 students, and we have all these data about people taking history, religion, math, but is it possible that somebody didn't take any? Well, of course, they might have just taken, say, science or whatever. So let's do the math on figuring out how many people didn't take math or the other classes, right? So let's say we have 72 total, and we need to subtract all the numbers that we put in the diagram so far. It's kind of tedious to write this out, but we'll be subtracting the 8 and the 3 and the 11, right? The 7, the 4, the 5, and the 12. Right, subtract all those numbers from 72. And eventually, you'll get to an answer of 22 leftover students. So 22 students that didn't take any of these 3 classes. Now, you'll put the 22 somewhere in the box that's not in one of the circles. On the computer assignment, I think it has you write it up in the top corner here, like 22. So we'll do it like that. So 22 students are outside of the circles but inside the box, meaning they're students, they took classes, just not history, math, or religion. Okay, so now we have everything set up. And so the nice thing is, I was talking about how the computer usually asks you 1 question at a time on these homework assignments. And I'm asking you 4 questions. But once you set up the Venn diagram, you only have to do the work once, and you can go through and answer any of these sorts of questions related to the situation. So for instance, how many students took only religion? So what that's a matter of looking at is looking at your circle that relates to religion, and when it says only religion, it means you don't want anything that touches the other circles. So notice that this part here, where the 12 is in the religion circle, but doesn't touch the history or math circles. So only religion would be 12. There would be 12 students that took only religion. Okay? In a similar way, you can answer each other question by figuring out what part of the picture is the question really asking about. How many took both math and religion? So when you're asked about that, that's that concept of the petals I was referring to. The part of a circle that's both the math and the religion overlap. How many took math and religion? Well, notice math and religion is that whole petal, right? Which was the 4 and the 5. So that's referring to the combination of those two. 4 plus 5 is 9. So we had the 4 and the 5 from the two parts of the petal, giving us 9 as the final answer. How many took math and religion? How many took religion but not history? Okay, so now notice that we have, again, the religion circle is being asked about, but only part of it, the part that doesn't touch history. So it's okay if it overlaps with math, just not if it overlaps with history. And so to clarify that, this part of the circle right, would be the religion circle, but not touch the history circle. That involves two parts of the 4 parts, 12 and 5. So 12 and 5 add up to 17. So there were 17 people that took religion but didn't take history. And then lastly, how many took none of these? Well, that was that last computation we did when we subtracted all the values in the picture from 72. And we got the 22. So there were 22 students that took none of these subjects. So again, all of these survey questions are a little bit different from each other, the way they'll be asked, as you see in different problems in your assignment or on your test. But they can all be approached in the same standardized way. Very systematic approach of drawing your Venn diagram from inside to out, and then identifying which parts of the picture go with which questions. So I hope this was helpful, and have a good day.